In this video, you will learn a little bit about correlation and regression. If you look at a graph of data, sometimes relationships become very apparent. The easiest one to demonstrate is a simple linear relationship between two variables. As one variable increases, the other variable also increases at a constant rate. For example, if you look at a graph that has data on miles driven on the x-axis and gallons of gas consumed on the y-axis, those data points will be pretty close to a straight line. In reality, we don't tend to have that perfect relationship, but perhaps there appears to be some sort of linear relationship between the two variables. Correlation is a measure of how closely the two variables are related. Correlation, typically abbreviated by R, will always be between -1 and +1. -1 represents perfect negative correlation, +1 perfect positive correlation, and 0 would mean no correlation whatsoever. The closer the absolute value of R is to 1, the stronger the correlation is between the two variables. The variable that we draw on the x-axis is typically called the independent variable, and the one on the y-axis is called the dependent variable. The idea is that the value of y depends on x, so y is the dependent of the two variables. However, we need to be careful. Just because the correlation is high between two variables does not guarantee that x causes y. There could be something else going on that isn't accounted for in those two variables. We can take this idea of correlation a step further and determine the equation that best represents the relationship between the two variables. This is called the regression equation. If the correlation is high enough, we can use the regression equation to predict what the value of y will be for different values of x that we don't have data for. This can be very powerful. Take a look at this example. Suppose you have some data on a neighborhood lemonade stand that shows you how many cups of lemonade were sold when the stand set various prices between 25 cents and $1.50 per cup. The price is the independent variable, and the demand in cups is the dependent variable. The equation of the regression line is 34.1 minus 16.3x, and the correlation between the two variables is negative 0.97. The correlation value is negative because the demand decreases as the price increases, as represented by the downward slope of the graph, and the absolute value of the correlation is very close to 1 because the data is very close to a straight line. Now, we don't have a data point for when the price is 60 cents, but we might want to predict what the sales would be if we set that price. Based on the regression equation, we can predict that at a price of 60 cents, the sales would be 34.1 minus 16.3 times 0.60, which is equal to 24.3 cups. Powerful. These predictions are only appropriate if we are reasonably within the range of the data and if we are predicting like things. For example, we wouldn't want to use this regression equation to predict how many cups we'd sell if we priced them at $20, or if we wanted to switch to selling water instead of lemonade.